Hi, in this video, we are going to look at some previous year's questions on straight lines. So I will look at the mains questions right now, and because mains exam is coming closer. So what I would expect from you is to try to solve the problems before you look at the solutions. Look at the question, pause the video and try to solve it yourself, and only then look at the solution. That is the way in which you will benefit the most from this video. And also go through the theory of the whole coordinate geometry series that we just now did in order to revise the theory. I will be bringing frequently these PYQs on all of the series that we are currently doing for JEE mains and advanced. So even if the series is over, occasionally I'll bring videos for previous year's questions for those particular topics to act as a revision for you guys. Also, like in the last few videos, I have seen that there are a lot of students who are actually watching the videos but have not subscribed. It would be very useful for me if you subscribe to the channel and help me also grow. That's how I'm motivated to provide more videos for you. So if you have already subscribed, please like the video and share it with your friends. And if you haven't subscribed, please subscribe to the channel. You will get a lot of content from now till the JEE mains and advanced exams next year, and that will help you prepare the math section definitely very well. So with that, I will start. This is the first question. This is JEE 2019. It says, suppose the points h comma k, 1 comma 2 and minus 3 comma 4 lie on the line L1 if a line L2 passing through h comma k and 4 comma 3 is perpendicular to L1, then find the value of k by h. So really obvious question. We know that these 3 points lie on the line L1, and we can find the slope of this line by simply doing slope between this point and this point. So slope of this line L1 is 4 minus 2, 2 by minus 3 minus 1 minus 4, which is minus half. And they have said that this line L2 is perpendicular to L1. So slope of L2 should be plus 2, right? And therefore, you can say 3 minus k by 4 minus h is equal to 2, right? And from here, we can easily find the relationship between h and k. We get 3 minus k is equal to 8 minus 2h, right? And therefore, you get 2h minus k is equal to 5, right? And therefore, you can write 2 minus k by h. Okay, actually, we have one relation here, 2h minus k is equal to 5. And we have the second relation, which will come from here, because the slope between these two is also going to be minus half, right? So we'll get from here 2 minus k by 1 minus h is equal to minus half. So you get basically 4 minus 2k is equal to minus 1 plus h. And you get 2k plus h is equal to 5, right? So 2h minus k is 5 and 2k plus h is 5. So 2h minus k is equal to 2k plus h. And you can get h is equal to 3k basically. And k by h is equal to 1 over 3, right? So a simple relationship based on the slopes. So it's not a very difficult question. Two lines are perpendicular, so the product of their slopes is minus 1. And let's move on now. This question was pretty easy. The next question is from JEE Mains 2019 again. If the two lines x plus a minus 1 into y equals 1 and 2x plus a square y equals 1, a belongs to real minus 0 comma 1 are perpendicular. Then the question is, then the distance of their point of intersection from the origin is how much? So basically they have said that these two lines are perpendicular. Slope of the first line is -1 by a minus 1. Slope of the second line is -2 by a square. And this is equal to -1 because they are perpendicular. So we get basically that +2. So 2 is equal to minus of a minus 1 into a square. And you are getting basically 1 minus a into a square. So a square minus a cube is equal to 2. You're getting an equation a cube minus a square plus 2 is 0, right? So we can write this as we have to be able to solve this equation. So let's look at some standard factors. If we can get a simple factor, then it will be done. I hope I've not made a silly mistake here. I'll just check once. So a cube minus a square plus 2 is 0. Yeah, it is correct. -1, is it a factor for here? You get a -1, -1. Okay, yeah, -1 is a factor, right? So if -1 is a factor, I can just write as a square into a plus 1 minus a into, so I got a square, so minus cube my plus a square. So I need a -2a plus 1 minus 2a square minus 2a, so plus 2a plus 1. Right, so you get basically a plus 1 common, a square minus 2a plus 2 equals 0. Now this can never be equal to 0 because this is a minus 1 whole square plus 1. So therefore this has to be 0, so this is -1. So basically I've solved the equation and found the value of a, and a has to be -1. And if a is -1, the two lines, you can easily write the simplified equation of the lines as x minus 2y is 1 and 2x plus y is 1, right? Okay, so solve these line equations. And in order to solve the line equations, I can multiply this with 2. 2x minus 2 into 2y is 2. And subtract, you get y minus minus 4. So 5y is equal to 1 minus 2 minus 1. So y is equal to -1 by 5. And therefore 2x is 1 minus y. So 1 plus 1 by 5. So 6 by 5. So x is 3 by 5. So the point of intersection is 3 by 5 comma -1 by 5. And the distance of the point of intersection from the origin becomes 9 plus 1, 10 by 25. So actually it is 2 by 5. So square root of 2 by 5 is the distance. That will be your answer to this question, right? So again, simple question. Two lines are perpendicular. From there, you have to solve this equation, find the a constant, and then find the point of intersection and finish the problem. Let's look at the third one. This question says, consider the set of all lines px plus qy plus r equals 0 such that 3p plus 2q plus 4r is equal to 0, right? Okay, which of the following statements is true? Which statement is correct? Statement is correct. And the first part of the statement is the lines are not concurrent. The lines are not concurrent. The second part is lines are concurrent at the point 3 by 4 comma 1 by 2. The third part is lines are all parallel And the fourth option is each line passes through the origin. Each line passes through the origin. The reason I'm writing these statements is because this is a conceptual question which you should understand. This is supposed to represent a family of straight lines. Family of lines. And usually the way we write family of lines is L1 plus lambda L2 is equal to 0. If we have the line equations, this is the family of lines passing through the intersection points of L1 and L2, right? But right now we have an infinite family of lines, not just passing through the intersection point of two given equations, right? So obviously you should understand that if P is 1, Q is 2, R is 3, you get a particular line equation, right? And if P is different, Q is different, and R is different, you will get a new line equation. So basically what I'm saying is for different values of P, Q, and R, the same equation is going to represent different lines. However, what has been said that this condition is always true. 3P plus 2Q plus 4R is always 0. So that means always, no matter what happens, P, Q, and R will take values such that 3P plus 2Q plus 4R is 0, right? So if I simplify this expression by dividing by 4, I will get 3 by 4 P plus 2 by 4 Q plus R is equal to 0. And this is true for all P, Q, and R. And now notice, if you put X is equal to 3 by 4 and Y is equal to 2 by 4 in the line equation here, Px plus Qy plus R, that means that equation is always true for all values of P, Q, and R, right? Because 3 by 4 P plus 2 by 4 Q plus R is always 0. So that means the point 3 by 4 comma 1 by 2 always lies on these lines, right? So the lines are therefore concurrent at 3 by 4 comma 1 by 2, right? We cannot say anything else. We cannot say that they are parallel lines and so on. Why? Because the slope of these lines is minus P over Q. We are not guaranteed that this value will be constant for all the lines, right? But we are guaranteed that no matter what the value of P and Q and R is, it will always satisfy this equation, which means it will always pass through this point, 3 by 4 comma 1 by 2. So I hope you have understood the concept of this question and how it becomes a question about a family of lines. Option 1 is incorrect. Option 2 is not necessarily correct. They could be parallel, but it's not necessary. And each line passes through the origin is incorrect, because if it always passes through the origin, then R should always be 0. But it is not necessary. That is not given to us, because if you put 0, 0 for X and Y, R should be 0 if it always passes through the origin. That is not necessary. Let's move on to the next question. Question number 4. It says, let the equations of two sides of a triangle be 3x minus 2y plus 6 equals 0 and 4x plus 5y minus 20 equals 0, right? If the orthocenter of this triangle is at 1, 1, the question is find the equation of the third side. Equation of the third side. Right. So it's a nice conceptual question. Let's think about it. We have been given the equations to two sides of the triangle, right? This is one side. Look at the slope of this line. The slope of this line is minus 3 by minus 2. So 3 over 2. And the slope of this line is minus 4 by 5, right? The orthocenter of this triangle has also been given. So let's assume this line is 3x minus 2y plus 6 equals 0. And let's assume this line is 4x plus 5y minus 20 is equal to 0, right? So AB and AC equations are given. we can find by solving these two equations, we can find the point A. So how do I solve these equations? I can multiply the first equation by 4. I'll get 12x minus 8y plus 24 is 0. And I can multiply the second equation by 3. So 12x plus 15y minus 60 is 0. And then subtract it, you get basically minus 23y plus 84 is 0, right? So you're getting y is equal to 84 by 23. That is the y coordinate of this point. It's a weird coordinate. The x coordinate will also come really horrible, I think. But we'll anyway have to find it. So 3x is equal to 2y minus 6. So that will be 168 by 23, 2 times y, minus 6. So 23 6 is 138, I think. Right, 138. So therefore you're getting 3x is equal to 168 minus 138. So 30 by 23 and x is equal to 10 by 23, right? So my point A is 10 by 23, comma 84 by 23, right? And the orthocenter is given as 1, comma 1. So the orthocenter is the line, is the point where all three altitudes intersect, right? So if I draw an altitude from A to this AD, and if I draw an altitude from B to here, BE, the altitudes intersect at the orthocenter, right? So right now, automatically, what I will know is the point 1, comma 1, and A we already know. So slope of AD line we know, right? Slope of AD would be 84 by 23 minus 1 divided by 10 by 23 minus 1. So it would become basically 61 by 23, 61 by minus 13. So minus 13 by 61 is slope of AD. So therefore the slope of the base BC should be 61 over 13, right? So that will be the slope of my segment BC, right? Great. If I know the slope of my segment is 61 over 13, now I can check the options and immediately eliminate some options. So from here, I will write down the options for you. The options for the third side's equation in the question are written like this. $122y plus 26x plus 1675 is 0. That is the first option. Then 26x minus 122y minus 1675 is 0. Then you have 26x plus 61y plus 1675 is 0. And fourth option is 122y minus 26x minus 1675 is 0. So all the options are very close, but the slope of our line has to be 61 by 13. It has to be a positive slope, right? So this is gone. This slope is minus 26 by 122. This is also wrong. This slope is minus 26 by 61, which is also wrong. And this slope is 26 by 122, right? I feel like I'm making a mistake with the slopes here. Wait, 61 by 13 is my slope. So I'm checking it incorrectly, right? 61 by 13 I have to check. Here I'm getting 26 on top, so that won't work. This is wrong. Here I would get a 26 on top again. Okay. And here I get a 61 by 26, right? that is just incorrect. And here I'm getting 122y minus 26x. So this is becoming 26 by 122. So actually, all the options are not matching. So maybe I'm making a mistake here. Let me just check the solution again. I'm making some silly mistake, I feel like. So let's see the line equations once more. One line was 4x plus 5y is equal to 20. One line was 3x minus 2y plus 6 equals 0, right? So the orthocenter was given as 1, comma 1, right? Okay. Now think about it. This is A, this is B, this is C. We need equation of BC, right? So what we can do is we can find the point A, right? Right. AC and this line are perpendicular to each other, and this line are perpendicular to each other, right? So we know the slope of this line. The slope of this line is minus 3 by minus 2, so 3 by 2. So I know the slope of this line, the altitude from B should be minus 2 by 3, right? And similarly, I know the slope of this line. The slope of this line is minus 4 by 5. So the slope of this line should be 5 by 4. The altitude from C, correct? So right. So if I know the slope of this altitude, I can actually write the equation of the line because I also know the point here, right? So equation of altitude, let's label it. This is D, this is E, this is F. Equation of altitude BE. By point slope form, it will be y minus 1 is minus 2 by 3 x minus 1, right? So this equation will become 3y minus 3 is equal to minus 2x plus 2. So the equation is 2x plus 3y equals 5. So I have gotten the equation of altitude BE, right? Because I knew the slope of the line BE, because that will be perpendicular to this line slope, and I already know a point on the line. Similarly, I will get equation of altitude CF would be y minus 1 is equal to slope of CF should be 5 by 4. So 5 by 4 x minus 1. So this becomes 4y minus 4 is 5x minus 5. And this becomes basically 5x minus 4y minus 1 is 0. This is my altitude CF, right? Great. Now that I know the equation of BE and equation of CF, I can actually find the point B by intersecting the lines AB and BE, right? Because AB equation is known, 4x plus 5y is equal to 20, and BE equation is 2x plus 3y is equal to 10. So that can be written as 4x plus 6y is equal to 10, right? 2x plus 3y was 5, so 4x plus 6y is 10. If you subtract, you get minus y is equal to 10. So y is equal to minus 10. If y is minus 10, x would be 2x is equal to 5 minus 3y. So 5 plus 30. So 5 minus 3y. So 5 plus 30, 35, 35 by 2. So my B point is coming out to be 35 by 2 comma minus 10. right? And similarly, I will find the C point also. How do I find the C point? By solving the line equations AC and CF, right? Equation of CF is this. Equation of AC is this, 3x minus 2y. So multiply this by 2, 6x minus 4y plus 12 is 0. And here you have 5x minus 4y minus 1 is 0. So subtract the two equations, you will get x, 4y will cancel, and you get x plus 13 is equal to 0. So x is equal to minus 13. And if x is minus 13, you have a minus 39 here, minus 33, and y is minus 33 by 2. This is minus 13 comma minus 33 by 2. So now I have both the points B and point C. And now the equation is pretty simple. It is the 2-point form equation of line BC. So basically I have found B to be 35 by 2 comma minus 10. And I have found C to be minus 13 and minus 33 by 2, right? And by 2-point form, I can write the equation as y minus minus 10, so plus 10, is equal to the slope of this line. Now see, it will come out to be 13 by 61 as I expected, I think. So it will be minus 33 by 2 minus minus plus 10 divided by minus 13 minus 35 by 2 times x minus 35 by 2. So this slope on top is becoming minus 13 by 2, and here it is becoming 26 and 61, minus 61 and 2. So this gets cancelled. You have 13 by 61 as the slope multiplied by x minus 35 by 2, right? So finally, we will get 61y plus 610 is equal to 13x minus 13 into 35 by 2. So actually it will become 122y minus 26x is equal to minus 13 into 35 minus 1220. So this will become your equation. So notice what technique we used. If you had a triangle like this, line 1 and line 2 equations are given and orthocenter point is given, right? So in the beginning, I was trying to do it with a different way. Orthocenter, I was trying to find the point A, but finding point A is actually not relevant. I was trying to do L1 intersection L2. That is actually not required. What I can do is draw a perpendicular like this, draw a perpendicular like this. Both the altitudes pass through O. So you already know one point on this line. And since I know the line equation L2 and L1, I know ML1 and I know ML2. Therefore, this slope would be minus 1 by ML2 and this slope would be minus 1 by ML1. And because of that, you know the line equation of these altitudes. If you know the line equation of these altitudes, you can solve line equation L1 and this altitude to find the coordinate of B. And similarly, you can solve L2 and this altitude to find the coordinate of C. And once you have the coordinates of both of the points, you can do 2-point form to solve the problem and find the equation of BC. Right? So that is the solution. Let's look at another problem. This is question number 5. If the line 3x plus 4y minus 24 is equal to 0 intersects the x-axis at A, y-axis at B, then in center of triangle OAB, where O is the origin, you have to find the incenter. Okay. So first of all, the line equation is 3x plus 4y is equal to 24. So we can write it as x by 8 plus y by 6 is equal to 1. And this is the intercept form of the line equation. So the x-intercept is basically the point 8, 0, and y-intercept is the point 0, 6, right? So now that we have this situation, A is somewhere here, 8, 0, O is here, and B is here, right? This is 0, 6. So notice that this is a right angle triangle, and we already know the third side also. This side is 8, this side is 6, this side is 10, right? And what is the incenter? Incenter will be the point of intersection of the angle bisectors, right? And angle bisectors would basically be like this. One angle bisector will be like this, dividing it into 45 degree, 45 degree like this, right? So this line is y is equal to x. So incenter should lie on y is equal to x. Should lie on y is equal to x line, right? Okay. Also, this is a right angle triangle. The incenter is like this. You should imagine this perpendicular and this perpendicular and this perpendicular to be same, right? That is the definition of incenter. So if my point is on y is equal to x line, the point's coordinate will be h comma h. So obviously these two perpendiculars are matching. And now we can take perpendicular from h comma h to this line and then say that that perpendicular distance should also be equal to h, right? Because these two perpendicular distances are equal to h. They have to be equal to each other. That is the definition of an incenter. It is equidistant from the three sides. So the incenter is equidistant from both the sides of the right angle and also equidistant from the side AB. So if the equation of AB is this, what is the perpendicular distance from h comma h to this line? It will be 3h plus 4h minus 24 mod divided by root over 3 square plus 4 square. And that should be equal to h. Then only if you will get the incenter, right? Because the perpendicular distance of h from the other two sides are h and h. Clearly, now we get mod of 7h minus 24 by 5 is equal to h. So 7h minus 24 is equal to 5h. You could get a negative sign also, but in this case, we are going in the first quadrant. So we'll take h as positive. You get 2h is equal to 24. H is equal to 12. Right? So okay, I have made a mistake somewhere here. 7h minus 24 by 5h. The perpendicular distance is the in radius right. So the in radius of the circle, maybe I made a mistake in some calculation. In radius of the circle is del by s. S is the semi-perimeter. Semi-perimeter here is 6 plus 8, 14 plus 10, 24 by 2, 12. So del by 12. And the area is half into 6 into 8 by 12. So this is becoming 2. So R is actually 2, right? So I know the in radius is 2. So automatically the point becomes h comma h should be 2 comma 2 actually. I am making some mistake in finding the perpendicular distance. Perpendicular from h comma h to the line would be 3h plus 4h minus 24, 7h minus 25 is 5h. Oh, okay. See what is happening. When I solve with the positive coordinates, I'm getting h as 12. But I could also have solved like this. 7h minus 24 is equal to minus 5h. And then 12h is equal to 24 and h is equal to 2. You're getting two possible values of h, 2 and 12. And that's why the answer is 2, comma 2. Here in this triangle, the answer 2, comma 2 makes sense because 12 and all will be outside the triangle, right? So I did it by properties of triangle and realizing that R in radius will be del by S, where del is the area of the triangle and S is semi-perimeter. But also from here, I had ignored the negative sign. Therefore, I was getting H as 12 and I was missing on the case that H could be 2 as well. So once you realize that H could be 2 also, while taking the negative sign, you will get the correct answer. The incenter here is 2, comma 2. There is another method to solve the problem, which is by using the incenter formulas. But I would recommend not to use that method because not all problems you will have the fact that the three coordinates are already known. The incenter formula looks like ax1 plus bx2 plus cx3 by a plus b plus c. But I would say that I would not recommend remembering so many formulas. So if you remember it, great, you can use it and you will get the answer in a single step here. Because all the three coordinates are known, you can use the result that incenter is a x1 plus b x2 plus c x3 by a plus b plus c, comma a y1 plus b y2 plus c y3 by a plus b plus c. But you can solve it without using this formula also, like we just now did, right? This formula basically means that if this is a point A, x1, y1, this is side A. Similarly, opposite to B would be side small b, and this would be x2, y2. And this would be C, x3, y3 coordinate, and opposite to C will be side C. So small a, small b, small c are the sides of the triangle. x1, y1, x2, y2, x3, y3 are the vertices of the triangle. Here in this problem, you already know all the three vertices, right? So you know 0, 6, 8, 0, and 0, 0. And you know length of the sides are 10, 8, and 6. So here it's a very direct application of the formula. And you can say 10 into 0 plus 8 into 0 plus 6 into 8 by 10 plus 8 plus 6, which is 24, comma 10 into 0 plus, now I'm doing the y coordinates, 8 into 6 plus 6 into 0 by 24. Notice that this is becoming 48 by 24, 2, comma, this is becoming also 48 by 24, 2, comma 2. That comes as your incenter. This formula is derived because we know that the angle bisector divides the opposite side in the ratio B is to C, and the incenter divides any angle bisector in the ratio A plus C is to B. So there are two theorems here that are working. I will just briefly tell you. First is the angle bisector theorem. So if this is an angle bisector A, B, C, and this side is B and this side is C, then this point D is such that BD by CD is in the ratio of BD and by CD will be in the ratio of C is to B here. That's the first result. And the second result is incenter AI will divide the angle bisector AI by ID will be in the ratio B plus C by the third side was A. So if you combine these two and apply section formula, you can derive the formula that I just now used. Okay. So that's it for this question. Let's move on to the next one. Question number 6. A point P moves on the line 2x minus 3y plus 4 equals 0. If Q 1, 4 and R minus plus 3, minus 2 are fixed points, you have to find the locus of centroid of triangle PQR. Okay, so very easy question. P is a variable point. So let's say P is a point it lies on this line. So if it has x coordinate as x, the y coordinate would be 3y would be equal to 2x plus 4. So y coordinate would be 2x plus 4 by 3, right? What am I doing here? I'm saying that if the x coordinate of P was x, obviously the y coordinate would satisfy this equation. The y coordinate would be this. So this reduces the number of variables I have. This is my point P. Q is given as 1, 4. R is given as 3, minus 2. So centroid of PQR would be basically x plus 1 plus 3 by 3 and 2x plus 4 by 3 plus 4 minus 2 by 3, right? So this becomes x plus 4 by 3, comma, this becomes plus 2. So plus 2 into 3 plus 6. So 2x plus 10. 2x plus 10 by 9. This is the centroid of the triangle PQR. So if I call the centroid as h comma k, I have h is equal to x plus 4 by 3 and k is equal to 2x plus 10 by 9. So I can eliminate x here. I can say x is equal to 3h minus 4 and put this in this equation. I will get k is equal to 9k is equal to 2x. So 2x is 6h minus 8 plus 10. So I'm getting 9k is equal to 6h plus 2. So k is equal to 2 by 3h plus 2 by 9. And this is the locus of the centroid. And you can see that it's a straight line with slope 2 by 3. Y is equal to 2 by 3x plus 2 by 9 is the required locus, right? So this locus is simple. It is a straight line with slope 2 by 3, right? The next question says, two vertices of a triangle are 0, 2 and 4, 3. If its orthocenter is at the origin, then its third vertex lies in which quadrant? Okay. So basically two vertices of a triangle are given and orthocenter is also given and we have to figure out where the third vertex is, right? That is the question. Let's draw a figure. Let's say first vertex is A, which is 0, 2. Second vertex is B, which is 4, 3. And we don't know third vertex, which is unknown h, k. And we know the orthocenter. This is my orthocenter O, which is 0, 0, right? Okay. And orthocenter is point of intersection of altitude. So these lines are perpendicular, right? Great. So now a lot of information is present in this figure. So notice that slope of AC is equal to k minus 2 by h minus 0. So k minus 2 by h. And slope of OB is the altitude to AC. Slope of OB is clearly 3 minus 0 by 4 minus 0, right? So we get 3 by 4. And these two slopes have to be perpendicular. So we have k minus 2 by h times 3 by 4 is equal to minus 1. So you get k minus 2 by h is equal to minus 4 by 3. So 3k minus 6 is minus 4k, 4h. And therefore I am getting 3k plus 4h is equal to 6. That is the first equation that we have gotten, right? Again, similarly, I can do slope of this altitude is equal to 2 minus 0. Actually, this is infinite slope, right? 2 minus 0 by 0 minus 0. So the slope of this must be 0, right? This altitude is perpendicular to the y-axis, so this line must be perpendicular to the x-axis, which automatically means that k should be equal to 3. And if k is equal to 3, we will get the value of h easily. Why is k equal to 3? Because this line has to be parallel to x-axis because this altitude was parallel to y-axis, since it was having infinite slope, right? And once you put k is equal to 3, you get 9 plus 4h is equal to 6. So 4h is clearly negative. H is negative. K is positive. So this is x is negative, but y is positive. So this is the second quadrant. So that is how we figure out this particular problem, right? Let's move on to the next one. Question 8. It says two sides of a parallelogram are along the lines x plus y equals 3 and x minus y plus 3 equals 0. If its diagonals intersect at 2, 4, then one of its vertex is, we have some options, 3, 6, 2, 6, 2, 1, and last option is 3, 5. Okay, so two sides of a parallelogram are given. Notice that the slope of this is -1 and the slope of this is +1, right? So these two sides of the parallelogram are actually perpendicular to each other. So if this side is x plus y is equal to 3, this will be x minus y plus 3 equals 0, right? So it could be this side or it could be this side is x minus y plus 3 equals 0, right? So in any case, the intersection point, first of all, what we are getting is it is looking like a rectangle, first of all, right? This is 90 degree is known and it's a parallelogram. So all the other angles will now become 90 degree, right? And these are the diagonals. Diagonals are intersecting at 2, 4. Okay, so right. So what we can say here is I mean, I can take cases and solve it, right? I can take this side is this side is this. And as soon as you do that, you will get this point, right? Then I don't know this particular side. You will get this point easily. What is this point? The solution of these two equations. X minus y is equal to -3 and x plus y is equal to 3. If you add the two equations, 2x is 0, so x is 0. If x is 0, y is 3. So this is 0, 3, right? 0, 3 is this point. And now I know the slope of the diagonal basically, right? Okay. So a random point on the this vertex is lying on this line x plus y is equal to 3. So I can take it as h comma 3 minus h. This vertex I'm taking as h comma 3 minus h. And now slope of this line is known, right? Slope of this line is 4 minus 3 by 2 minus 0. So 1 by 2. So line equation is known, this diagonal, correct? the equation of diagonal will become, because one point is known and the slope is known. So therefore, the equation of diagonal is y minus 4 is half into x minus 2. So that is 2y minus 8 is equal to x minus 2. So you get 2y minus x is equal to 6. This is the equation of my diagonal, and obviously the slope of the diagonal right now is coming out to be, slope of this diagonal is half, right? Okay. And I know the slope of this line. The slope of this line will be parallel to this line. So slope here is 1, right? So slope here is 1. Okay, I forgot I can find this other point directly because diagonals of a parallelogram bisect each other. So this 2, 4 is the midpoint. And we already found this as 0, 3. So this should be 4, 3 plus y by 2 is equal to 4. So 4, 5 is this point. So because I had forgotten that, I thought that this point is unknown. Now I know this, right? So because I know this point as 4, 5, it has come because the diagonals of a parallelogram bisect each other. Now that you know this is 4, 5 and we know slope is 1, I can find h, 3 minus h easily. Why? Because slope between these two will be 5 minus 3 minus h. So 2 plus h by 4 minus h should be equal to 1. So you get 2 plus h is 4 minus h. So you get 2h is equal to 2. So h is equal to 1. So the point here can be 1, 2. So this point has to be 1, 2. Then this point, the other vertex of this diagonal, would be 1 plus x by 2 is 2. So it will be 3, 2 plus y by 2 is 4. 3, 6. So basically this vertex is 3, 6. This vertex is 4, 5. This vertex is 1, 2. And this vertex is 0, 3. And I have found all the 4 vertices of that parallelogram, right? So remember what we did here. The method is important. We have come up with a method. We got 2 line equations were given. These 2 line equations were perpendicular to each other. We intersected them and found the first vertex. Then we took one of the other vertex as h, 3 minus h because it lies on the line x plus y is equal to 3. Then because the diagonal was given, the diagonal is the midpoint. So we know the opposite vertex immediately. It is 4, 5. And 4, 5 and h, 3 minus h, the slope between them has to be equal to 1 because the line equation of the parallel line was given. And from there we got the value of h. And once we get h, we can also find the other vertex, right? Because of the other diagonal being midpoint property. So that basically helps us find the equations of all of the vertices of this parallelogram. So we have done 8 questions today. These are all questions from JEE mains. You should try and solve more previous year's questions to get the hang of this chapter. We will continue to do PYQ videos for straight lines and circles in the next week. So expect a few more videos on that. And we will obviously continue the vector and 3D geometry series. Right? So I'll see you next time. Please subscribe to the channel and share it with your friends. The content here will be very useful for you for your math section in JEE mains and advanced. So follow the channel for the next 8 months and you will ensure that you will definitely improve your math scores. That's it for now. I'll see you next time.